Yellow test continued, number 5. Okay, we have a motion of a circus clown on a unicycle moving in a straight line is shown in the graph below. Here's our velocity time, and it says what would be the acceleration of the clown at 10 seconds. Okay, so if we have a velocity time graph, it's the slope of the line that tells us the acceleration. So for number 5, it's going to be the slope of this line right here at 10 seconds. So right here. Since this is a constant negative slope, then I can calculate the slope of the whole line to get the acceleration at that specific time. So change in y-axis, so I'm going to pick 8 and 12 seconds. Change in y-axis is at, let's see here, starting up here, at 8 seconds, we're moving 10 meters per second. At 12 seconds, we're moving 0 meters per second. So 10 is y1, 0 is y2. So I want to get y2 minus y1, so 0 minus 10 is negative 10, divided by x1 is 8 seconds and x2 is 12 seconds. So x2 minus x1, 12 minus 8 is 4. Okay? And I'm not doing a good job here showing my units, but this right here would be meters per second divided by seconds. Put that in a cross because that's what I always preach on, and that's meters per second squared. Okay? So negative 10, whoops, I don't know why I said a negative 4, just 4. Negative 10 divided by 4 is negative 2.5. My answer here is C. Okay? Answer is C. Okay, number 6. After 4 seconds, how far is the clown from her original starting point? Okay? So 4 seconds, I'm looking for a displacement right here. I need to find the displacement of this area, and I don't know an equation for displacement of that area, so I'm going to break this into a tall, skinny triangle here and a rectangle. So this right here would be 1/2 base times height. So I would have 1/2, the base is 2 seconds long, and the height is 6 meters per second high. Okay? You see no crosses, it's hard to tell what cancels. And so, let's see here, 2 times 6 is 12, and 12 times 1/2 would be 6 meters. So it covers 6 meters in the first 2 seconds, and then in the second 2 seconds, it's just simply base times height. So that's another 2 seconds, from 2 to 4, that's 2 seconds, and height is 6 meters, so 2 seconds times 6 meters per second is 12 meters. So 6 plus 12 is 18, so my answer for 6 is A. Yeah, 6 is A. Okay, number 7. Which of the following pairs of graphs can possibly be describing the same object? Okay, so each one is a position time graph followed by a velocity time graph. So here we have a positive decreasing slope. So that means I need a positive decreasing velocity. That would look like this. So those two don't match. Okay, I need a positive decreasing. Here I have a positive slope, so I've got a positive velocity, but I have a positive, positive decreasing again, same thing. So that would still be that. Here I have a constant positive velocity, so that would be something like that. Here I have a increasing positive velocity, so I'm going to go like this. Increasing positive velocity at a constant rate. This right here is an increasing positive velocity at not at a constant rate. Okay, here we have an increasing positive velocity, increasing positive velocity. So my answer here is E. Oh, well, E is not down here, so my answer is D. Okay, number 8. The graph here shows a velocity versus time graph for a car. What is the acceleration at 90 seconds? and we come to 90 seconds. Now this does not make a constant slope, but if you look kind of in this region, it does. You could get the slope of the line using these 2 points, or you could get the slope of the line using these 2 points. Okay? And since this is a constant slope right in this area, whatever the slope of this line is, it has a constant acceleration for this amount of time. So whatever the slope is, the acceleration is the same right here. Okay? So if I plug in my change in y, I'm just going to pick these 2 points. It would be 20 minus 30. Sorry. Did I do that right? Oh, sorry. 30 minus 20. So that would be 10 meters per second. This happened last, so that's y2 minus y1 divided by x2 minus x1. So from 90 to 120, that's 30 seconds. So 10 divided by 30 is about 0.33, right? Line over it maybe. Meters per second squared. So that would be B. Okay, moving on to number 9. I think this was maybe the most commonly missed question right here. It says, shown below is a velocity versus time graph for a toy car moving in a straight line. What is the displacement of the car from 2 to 3 seconds? So remember, on a velocity time graph, we can get the displacement by calculating the area under the line. So here's from 2 to 3 seconds, the line does this. Okay, here's my timeline. So I need to get this area and this area, and then add those 2 areas together. Well, it turns out that this area is a positive number, and this area is the same number, but it's negative. You would use 1/2 base times height for both of these, but due to time constraints, my video, I don't want it to mess up on me. I'm not going to calculate it, but it would be 1/2 half a second times 2 meters per second. And then this one, from 2.5 to 3, would be 1/2 half a second times negative 2 meters per second. So you get the exact same answer, but one is positive and one is negative. When you add them together, the displacement between 2 and 3 seconds is 0. Okay, number 10. What kind of velocity is the object experiencing during the full 3 seconds of the position time graph to the left? Okay, so we have a position time graph here. We have a constant negative velocity because we have a constant negative slope. Remember, the slope on a position time graph tells you what the velocity is. So if you have a constant slope, it's a constant velocity. If you have a negative slope, it's a negative velocity. So I have a constant negative velocity. Okay, watch the other test if you want to review a little bit further.